Well, again, this is the Pencrest High School AP Physics C video series. This is video 3E, Work and Kinetic Energy Principle. The work kinetic energy principle is another statement of conservation of energy. We're going to look at the approach that we took last year and show how this approach is effectively the same with some of the same similar terms but with different names. If necessary, you may need to review the process on page 89 of last year's AP Physics 1 notes. We consider points A and B and the mechanical energy in all its forms at those 2 points, decide if there's any work done in between based on if there's an applied force or friction, and then we establish the relationship as follows. The energy at A, again in all its forms, plus or minus any work done, is equal to the energy at B, again in all of its forms. This is, for our purposes, again limited to the forms of mechanical energy that we're familiar with, kinetic energy, gravitational potential energy, and elastic potential energy. If by some chance all 3 forms of energy were present at both locations and there was work done in between, the relationship might look as complicated as what you see here. Here's the kinetic energy at A, the gravitational potential at A, elastic potential at A. So there collectively is the energy at A, plus the work done by the applied force, minus the work done by friction. And then on the right, kinetic energy at B, gravitational potential energy at B, elastic potential energy at B. Again, this is about as bad as it could be. What we're going to do is move some terms around and use this to generate the work and kinetic energy principle. So we're going to take this initial kinetic energy term, we're going to subtract it from both sides and effectively move it to the right. We're going to take the gravitational potential energy and elastic potential energy terms at point B. We're going to subtract them from both sides and move those effectively from the right to the left. And we're going to sort of gather the gravitational potential energy terms, the elastic potential energy terms, and then on the right, the kinetic energy terms. And we're going to factor some things out and give some terms new names. So keep in mind, as we look at these, that anything with a subscript A indicates that location in the problem. Typically we would call that the initial condition, and then subscript B refers to the final condition. So on the left, we have factored out the mg, and then we have h sub A minus h sub B. So effectively the initial height minus the final height times mg. This is a new term for us. This is something that's called the work done by gravity. We're used to using these 2 terms and looking at these 2 terms as a change in the gravitational potential energy between A and B. We would typically determine that by doing final minus initial. You can see that this is initial minus final. So what we call the work done by gravity is the negative of delta U sub G. Okay, so that's a new idea. but it's something that the College Board uses, and the Physics C exam will typically indicate somewhere in the multiple choice section of the exam. So this mg, initial height minus final height, you can see that if the object descends, so if the initial height is greater than the final height, this work done by gravity term would be positive. And if the object is elevated, if HB is greater than HA, then the work done by gravity would be a negative term. Okay. So this term here, we have 1/2 k xa squared minus 1/2 k xb squared. We're going to factor out the 1/2 k, and we have the initial deformation of the spring squared minus the final deformation of the spring squared. This is what we would call the work done by the spring. We do want to make a distinction between the work done by the spring and the work done on the spring, because they are effectively opposites. So in this case, if this is a positive quantity, that would imply that the initial deformation was greater than the final deformation, implying that the spring sort of gave up some of its energy. So if the work done by the spring is positive, it's giving some of its energy to the surroundings. Conversely, if the final deformation is greater than the initial deformation, that would imply that this work done by the spring is negative. In which case the spring is actually taking energy away from the surroundings. So the spring would have more energy in it at the end, at point B, than it did at point A. So we do want to make that distinction, work done by the spring and work done on the spring. The other two terms here, FAD cosine theta, mu FND, no different than they were before. We're familiar with those already. So we'll move to the right side. 1/2 mv squared minus 1/2 mv a squared. This is effectively final kinetic energy minus initial. This is the change in the kinetic energy. So what we have is an even simpler form of the conservation of energy. The work done equals delta K, and the work done implies the work done in all of its forms. So we are effectively consolidating the gravitational potential energy terms and elastic potential energy terms into these new ideas that we call work done by gravity and work done by the spring, to get effectively the work done in all of its forms. And that delta K is the change in the kinetic energy based on these other terms that we've seen. So we kind of went from simple to complex, and then did some manipulation, some algebra, and back to a very, very simple looking formula. So this is the work and kinetic energy principle. We want to focus when we do problems of this type on specifically the new ones. So the work done by the spring, the work done by gravity, and we will take it from there. Typically in free response problems, the Physics C exam will not specify a method. So you could use the original conservation of energy that you learned, or you could use this one. In the event that they ask you about work done by the spring or work done by gravity, they would expect you to use this version. So that's more likely to show up in a multiple choice question than an FRQ. Okay, so that's all, and we'll be focusing on this for the next couple of days, including the experiment that will have both of these new terms in it, work done by the spring, work done by gravity, and also delta K. So so that's it for now, and until next time, enjoy. We'll see you again soon.